Okay, so one of the features of C++ there's not a feature in most languages is you can overload your operators to do different things. So in this context, the plus operator goes in and does a numerical addition, right? We're going to add a 5 to a 5, we're going to get a 10 out of it, and that's what that operator is meant to do. We've also got an assignment operator here that is going to assign that value to this variable. When we overload something, what does that mean? Think of overloaded functions. We can do different things. You know, we can do the same thing in C++. We can have a string we can have another string and we can add string 1 to string 2. Same operator, different context, and different results. What does it do in this case? Yeah, we're going to concatenate these two strings. We'll say, hey Bob. Hey Bob. So that works just fine. The reason this works is because the plus operator has been overloaded for the string class. Right? String is a class. And you can do the same thing in your own classes. By the way, this is also an overloaded operator. The insertion operator has been overloaded to work with cout the way it does. And so I'm going to show you how to do that, how you can overload your own operators. And this is not something that is needed, that's why it's not in a lot of languages, but it is very convenient to be able to do this. So we're going to do a silly example, and then we'll do a more practical example. So we'll come up here above main, and we'll make a class for a dog. And a dog will have a name, and it will have a weight, and it might have some other stuff, but that's enough for now. And we'll give our dog a constructor to set some default values. So the name will be Rover by default, and the weight will be 2.5 whatever. Do what? Too small? I wanted to add these two objects together. What does that mean? What data type do I need right here? Huh? What? Who said it? Somebody said it.
Was it a double?
A what?
A double?
No, it's not a double. What, Jay? Cat dog. Right, because everyone knows when you add a cat and a dog together, you get a cat dog. But what is catdog, and how do you add the two together? So we'll come up here and make another class It's important that you put this above the first two. Class catdog here. And so now I have a catdog, but it doesn't know, forgot the name here, catdog. It doesn't know how to add the two together. It doesn't know what that means. And so this is where overloaded operators come in. You can come in and define what it means to add two objects together. So we're going to go to whatever class is on the left here. And you can kind of think of this as a function. But we're going to go to the class on the left. That's going to be the cat, left of the operator. And we are going to overload the plus operator so that if a dog is added to a cat, we can create a cat dog. So back in the cat class. To overload an operator, you're going to start off with a return. What is the result of this operation? What are we going to get by adding a cat and a dog together?
We're just adding a weight or both this name and weight.
We'll do both, but what data type are we getting? Cat dog. And you're going to write the word operator, and you're going to tell it what operator you want to use. And then, in parentheses, you tell it what interacts with this operator. And you give it a name. And so this should look just like a function here. It's the same as if I had written a function called add that returns a cat dog. A dog is passed in. I'm in the cat class, so I already have a cat that I'm working with, and this would just be a function. But we can reduce it to an operator. And this is why a lot of languages, I think, just don't bother with overloaded operators, because really this is just a cute way of writing a function. There is one difference though. When you overload the operators, if you were to use multiple operators in one line of code, it does follow PEMDAS. So if you try to add a cat and multiply a cat in the same line, it's going to do multiplication first, regardless of what order you wrote it in. Which is weird. I didn't know that. We kind of figured that out working on our game, but you overload operators, it still follows PEMDAS. Otherwise, it's just like a function. So you can put in here whatever it means to add a dog to a cat. You can say that we want to create a cat dog. We want to have this cat dog have a name that is the same as the cat's name and the dog's name. You can even put a space in here if you want to. And the cat dog can have a weight that is equal to, let's say, the cat's weight plus the dog's weight. And then we take an average of the two, so we divide by 2 or multiply by half. And once you've done everything you want to do, when this operation takes place, you return that object. So we said up here we're going to return a cat dog from this operation, and we need to do that. And that's what we'll do. And now our code should be happy. It understands what it means when I say I want to add a cat to a dog. And to verify that this actually worked, I can say cout cat dog dot name. Let's go ahead and label that. And we can check the weight. And run the program. And you see that we get a cat dog whose name is Fred Rover, and the weight is the average between the cat and the dog. Any questions on that?
For the catdog operator, could it have gone in dog the same way it went into cat?
So the way it is right now, we can't do that.
So if we had put dog plus cat
That would not work.
as it is now?
Right. To make that work, you would have to switch. You would have to overload the operator for dog, just like we did here. But the problem is it cannot see cat because cat is written afterwards. So it doesn't know what it means to pass in a cat. Now you can use inheritance and derive both of these classes and then pass them both in as animals, and that works. But at least in the example I have here, you can't overload both of them because of the order. I think you can do it with pointers. I tried that yesterday and I failed, so I'm going to have to look up, I'm going to have to play with it and figure out how to do that, but I'm sure it can be done. But as it is, this only works with cat. We can only add a cat to a dog. Any other questions? Do you see how this is just a fancy function? Anybody? So if I wanted to, this could just be a function called add, and instead of saying cat plus dog, I could come down here and say cat dot add, and this is all something you have seen since intro, and that gets the same result. Right? It's just kind of cool to be able to put a plus there. And then this up here lets you operator, overload the operator, and it behaves like a function. Except for that it does follow PEMDAS, and function calls would still follow the order that you wrote them in. All right, let's take 5 and we'll do a more practical example. And then I would say this x equals x, this y equals y, z equals z. Why did I put this there? What does that mean? This pointer. Why did I do that? Nobody knows.
I've never seen it.
What? Does this work? Can I do that? Why?
Because you're not specifying.
It doesn't know which one. Is it this x or is it this x? Well, this is a pointer to the current object. Right? So the current object's x is equal to this x, the x that is being passed in. And Visual Studio color codes it for you. I put this one in gray and put this one in white so that you know it knows what you're talking about. But this is pretty common convention. If you don't like doing it that way, you can come up here and just name these something different. Sometimes you put an underscore, or you can just make them capital. There's something to differentiate between what's there and what's being passed in. But conventionally, you would see it done like this, especially in Java. I do this a lot in Java. And then another way to do it is to make an initialization list. And if you do the initialization list, this is actually the correct way to do it. You don't need this. If you do it this way, it creates the object, initializes these guys to junk, and then assigns them values. Sorry, initializes these guys to junk and then assigns them these values. But if you do an initialization list like what I have right here, it creates them and assigns the proper values at the exact same time. So that's another way of doing it. All right, we've got our vector up here. Let's create two vectors. We will have position vector. And I can say my position is at 100, 0, 0. And let's see, I have a velocity vector, and that is at 40, 20, 0. And then it's common to say something like or I can say velocity equals velocity plus position. No, that's wrong. Position equals position plus velocity. That's what I would like to say. Of course, it doesn't know what it means to add those two vectors together, and this is where overloaded operators come in really handy. Because to do this manually, I would have to say position dot x equals position dot x plus velocity dot x. And then I would have to write that again for the y, and I would have to write it again for the z. And you see how my code is 3 times longer if I don't have overloaded operators. Or I could write a function that adds the two together. But this is more intuitive, and C++ will let us do it. So let's do that. For this operation to take place, what am I returning? B3D. Operator, what am I passing in? Well, plus sign is the operator, but what am I passing in? B3D. Let's call it back. And what happens in here? I got to create a vector. I'll just call it V. V dot x equals x. That's the x of the current vector. In this case, it'll be positions x plus what? Vec dot x, the one I'm passing in. And we do the same thing for y. And the same thing for z. Now I've had to write all that out, but I only have to write it once. And we want to return v. Now when I do this operation, I should be able to, actually let's just write a display function for the vector. And that will show all of my coordinates, all of my values, and I can call that on position before the operation and after, just to see if my operator is working correctly. Does it work? It works just fine. What are the values for acceleration? As I have it right now, what are the values? Why is it 0?
Because it's not accelerating.
No, because I put 0 in the default constructor. If I don't pass anything in, it initializes all of these guys to 0. And to put it in perspective, what does that look like? If this is an object in a game, what is my position here?
It's on the x-axis.
Let's say this is X and this is Y and Z is coming out of the board. Where's my position? Let's say this is 0 and this is 200.
Sitting right in the middle on the line.
On the line? Why is it on the line?
Because
Yes, y is 0.
Because it's tough.
Y is 0?
Yes.
So we're right here.
And Z is 0, so it's on the x-axis.
It's right here on the chalkboard,
Yep.
whiteboard. And then velocity, what does that mean? 40, 20.
That's
What
how much
it's
it's
moving.
moving every second.
It's current movement.
Which direction is it moving?
It's to the right and up.
To the right, how much?
40.
40. So if that's 50, this would be about 40. And then how much up?
20.
So about half of that would be like this. So he's moving in this direction at that speed. Does that make sense?
Yeah.
That's what these vectors indicate. Is he speeding up?
No.
Is he slowing down?
No.
No, just cruising. Because acceleration is 0. That's what that means. All right, any questions about this? We're going to do this for the lab, but you're only going to be using 2D vectors. You're going to have to add a lot more operators. Sometimes it's necessary to subtract vectors. Sometimes it's necessary to get a dot product. If you want to know the angle between two vectors, you need a dot product. So you'll be doing that, but you'll only be doing it with 2D vectors. And we're going to come back and use this later to put in some graphics. So I can show you how to work with graphics in C++. It'll be a little more fun, and this will be a little bit practical.
I'm getting an error message.
Yes?
It says the V3D operator must return a value.
Did you forget that line?
Yeah.
Hmm?
What is slash T do?
It tabs over.
Oh, tabs over. Okay.
That's an escape sequence for tab. So that's why you display the values. I get these 2 spaces here, these spaces there. It keeps everything lined up at least to a point. As long as the values aren't too big, it will keep it lined up.